Assalamualaikum and hi everyone. My name is Ahmad Najmi bin Muhammad Zaki. I am final year student for Electronic System Engineering studying in Malaysia Japan International Institute of Technology, University Technology Malaysia. My final year project title is Design of Combined ANFIS-FFNN Tool for Identifying Faulty Protection Devices in a Test Distribution System. Let's start with introduction first. So the power system are constantly exposed to fault occurrences. Power system need to be monitored frequently in order to successfully supply the electric power continuously to the consumer without any or less error. To acquire a good quality and better power system in delivering the power supply, the smart fault diagnosis system need to be installed in the distribution system, such as identifying faulty protection devices. The IEEE 34 nodes that consist of single feeder and 8 lateral lines has been selected as a test distribution system for this project. Circuit breaker CB and fuses F are the protection device that has been installed in this test distribution system. The location of this device installed in test distribution system are shown in figure 1 here. Generally, utilities should achieve an acceptable index level such CAIDI, Customer Average Interruption Duration Index, so as to provide continuous and better service to the customer. The combination of Adaptive Neuro-Fuzzy Inference System ANFIS and Feed-Forward Neural Network FFNN have been selected to perform an identification of fault protection device in the distribution system. This approach will give less time to locate precisely and identify a fault protection device with low absolute error, so the system achieves an acceptable index level of CAIDI. Next is the problem statement. The current method for detecting malfunctioning protection device in a distribution system is by relying the information from alarms and protective relay signals. However, most of distribution systems are not completely equipped with alarm and protective relays. There are other methods that's more efficient and precise, which are by incorporating SCADA and energy management system. Nevertheless, it requires high cost installment of voltage and current sensors. The alternative technique, instead of relying on methods that have been mentioned above, is by using the combination of ANFIS-FFNN. For the objective and the scope of study, the objective of this study are to design a graphical user interface GUI for precisely identifying faulty protective device using an ANFIS and FFNN combination. And also, it's to reduce the absolute error for the final outcome. The scope of the study is to select the test feeder as a standard distribution power system, which is IEEE 34 node. Next is to create the input data, which are the fault point based on the location of the protection device in distribution power system. Then the ANFIS-FFNN will be trained using data of the fault point before configure the block of trained ANFIS-FFNN for generating output target in terms of binary number 1 or 0. Lastly, the scope is to design a GUI in order to display this number for a particular fault point. For the methodology, to finish this final year project, firstly, literature review has been made according to this title. Next, identifying the problem statement, objective, and the scope of study has been made. After that, for data collection, 5 fault points represented as input data have been created according to the location of the protection device in the IEEE 34 node. After that, this data has been used to train by using ANFIS-FFNN tools and design the structure of ANFIS-FFNN structure by using Simulink. Then the outcome of the structure has been analyzed whether it accepted or not according to the expected outcome that has been created in the data collection. The GUI has been designed after the outcome of the structure of ANFIS-FFNN in Simulink is acceptable. Finally, the final report for final year project 2 has been made. The figure 3 here shows the implementation procedure to design the ANFIS-FFNN structure. Each main block consists of ANFIS and FFNN structure that combine together. Since there are 2 circuit breaker and 9 fuses in the test distribution system, so in this design there are 11 main blocks, where each main block represents of a protection device in the test distribution system. There will be 2 input for the ANFIS-FFNN structure, which are the fault points X and Y. The result in this work are, firstly, I have successfully created 5 fault points just like in figure 4. The access symbol in the figure 4 are the location of the fault point. The state operation of the protection device that near to the fault point will be non-operative or zeros. So in this case, the state operation of the protection device for F1, CB2, F6, F7 and F8 will be 0. These input data are created in Excel so that it can be used in MATLAB. After train the input data, the block of ANFIS and FFNN were created in MATLAB. These blocks were arranged in Simulink just like in figure 3, where the input data trained in ANFIS first, the white box, and then it will be trained by FFNN, the blue box. The final outcome for this work is to display a GUI design for this system. I have designed the GUI just like in the figure 6, where the input can be inserted in the fault point segment and the push button must be clicked to get the output. The status of operating state of the protection device will be presented next to the label protection device and should be round off to get a binary number. For example, the status operation for F1 in figure 6, if we round off it, we will get a 0. Ones and zeros are interpreted as operating and non-operating device respectively. For the error of the system, here the table 1 shows the average maximum absolute error for ANFIS-FFNN method and ANFIS method. This table shows that for ANFIS-FFNN method have 1.32 to the power of -6, while ANFIS method have 1.81 to the power of -6 for average maximum absolute error for a particular fault point. This shows that the ANFIS-FFNN method produce a better system than using ANFIS method only, since it has the smallest error for the system. The conclusion for this work is identification of faulty protection device in a power distribution system is very important for increasing the quality and the reliability of the system. This experiment demonstrates that by using the combination of ANFIS-FFNN also can produce a good identifying faulty protection device system without relying on alarm and protective relays information. The result shows that the purpose of ANFIS-FFNN method is reasonably accurate in identifying faulty protection device when properly designed for a selected distribution system. It also produces a better system for identifying faulty protection device in terms of maximum absolute error. It shows the ANFIS-FFNN produce less maximum error compared than using ANFIS alone. In this project, I only trained 5 input data and it shows satisfactory result. It is possible to reduce more error in this system by training a lot of data. The smaller the error, the better the performance of the system. That's all for me. Thank you for listening.